The Bernoullis were an aristocratic family, most notable for producing quite a few mathematicians during the 17th and 18th centuries. The Bernoullis collectively made incredible contributions to mathematical analysis, mathematical physics, and probability theory. In this series, we will be covering the following Bernoullis. Nicolaus Bernoulli, born in 1623 and a non-mathematician. Jacob Bernoulli, born 1654. Nicolaus Bernoulli, born 1667, another non-mathematician. Johann Bernoulli, born 1667. Nicolaus Bernoulli I, born 1687. Nicolaus Bernoulli II, born 1695. Daniel Bernoulli, born 1700. Johann Bernoulli II, born 1710. Johann Bernoulli III, born 1744. And Jacob Bernoulli II, born 1759. Nicolaus Bernoulli was the father of Jacob and Johann Bernoulli. He was born November 19, 1623, in Basel, Switzerland. He inherited a spice business in Basel set up by his father. The original business was started in Amsterdam, but it was moved to Basel in 1620 due to political and religious unrest from the Spanish rule in the Netherlands. Nicolaus was not a mathematician, but was nonetheless important to Basel, as he ended up becoming a member of the Basel Town Council and a magistrate. Nicolaus ended up marrying to Margaretha Schönhauer. The Schönhauer family was known in Basel for its bankers and local councillors, so they too were quite important to Basel. From 1647 to 1669, the couple gave birth to 11 children, Jacob being the 5th, Johann being the 10th. Margaretha died in 1673, and Nicolaus ended up remarrying to Verena Keller, whom he would stay with until his death on March 8th, 1708. Jacob Bernoulli was the son of Nicolaus Bernoulli, and he was notable for being the first mathematician of the Bernoullis, being one of the founders of the calculus of variations, Bernoulli's method, discovering the constant E, and the law of large numbers. Jacob Bernoulli was born December 27, 1654 in Basel, Switzerland. Jacob was persuaded to study philosophy and theology by his parents at the University of Basel. He wasn't passionate about it in the least, but still ended up getting a master's in philosophy and a licentiate in theology, allowing him to go into the ministry. During his time at the university, he was able to study mathematics and astronomy. This greatly influenced Jacob's travels across Europe from 1676 to 1682. On these travels, he learned about the latest discoveries from leading figures in mathematics and science. Once Jacob was done traveling, he returned to Basel. He began teaching mechanics at the university in 1683 and was appointed professorship and chair in 1687. Between 1684 and 1689, Jacob wrote Ars Conjectandi, Art of Conjecturing in English, one of the earliest works on probability theory. Among the many important results discussed in this book, Jacob introduces Bernoulli numbers and the law of large numbers. Despite this book being written in the 1680s, this book wasn't actually published until 1713, 8 years after Jacob's death. In 1682, Jacob married Judith Stupenus. The couple had 2 children, neither of which ended up pursuing mathematics or science. Jacob and his younger brother Johann were amongst the first to really understand, apply, and thus promote calculus. They studied Leibniz's 1684 paper on differential equations titled Nova Methodus Pro Maximus et Minimus. This paper was quite obscure at the time, so if the Bernoullis hadn't been such big proponents, there probably would have been quite a delay in calculus's growth. Jacob and Johann worked quite well together on calculus and other problems until the early 1690s. Johann began boasting of his abilities, which really angered Jacob. Jacob tried putting this boasting down by saying that Johann was a student, his only achievements being regurgitating information taught from him. Based on the work that Johann had been doing and what he'd published, this was clearly a false statement. Clearly, Jacob was feeling insecure about his brother's talents, regardless of how cocky Johann was becoming. Their relationship completely crumbled in 1697 when working independently on the Brachistochrone curve problem, which was finding the equation for the path followed by a particle from one point to another in the shortest amount of time if the particle is acted upon by gravity alone. Jacob's answer to the problem was correct, whereas Johann's was incorrect, and Johann presented Jacob's solution as his own. The souring of their relationship was never resolved, existing up until the point of Jacob's death on August 16, 1705. Nicolaus Bernoulli, born 1667, was the son of Nicolaus Bernoulli, born 1623. He was a painter and alderman of Basel who never pursued mathematics. Not much is known about him other than him being the father to Nicolaus Bernoulli I, who would go on to pursue mathematics. He died in 1748, the same year as Johann, his brother. Johann Bernoulli was the son of Nicolaus Bernoulli, 1623, and brother of Jacob Bernoulli. He is notable for being one of the founders of the calculus variations and being the primary author of L'Hopital's book on infinitesimal calculus. Johann was born August 6, 1667 in Basel, Switzerland. Johann began attending the University of Basel in 1683, where Nicolaus wanted Johann to study business so he could take over the family spice trade. Johann convinced his father, though reluctantly, to let him study medicine instead, to which he obtained an MD in 1694. Johann wasn't particularly interested in medicine either, and was studying infinitesimal calculus with Jacob while attending university. About a year after graduating, Johann married Dorothy Faulkner. They had quite a few children, 3 of which became mathematicians: Nicolaus II, Daniel, and Johann II. Soon after getting married, Johann, his wife, and their 7-month-old child, Nicolaus II, traveled to Groningen, Netherlands. They traveled from September 1st, 1695 to October 22nd, 1695. Since Jacob had the chair at the University of Basel, Johann accepted a professorship in mathematics at the University of Groningen. He taught differential equations and did research there. Issues arose during their time there, which included religious disputes, their second child dying just 6 weeks after birth, and people perceiving Johann's physics experiments as objectionable. Johann and his family returned to Basel in 1705 per his father-in-law's request. Jacob had died before they'd arrived back, so this allowed Johann to take his brother's chair at the university. As was mentioned in the discussion about Jacob Bernoulli, we know that Johann had problems with Jacob. Alas, issues didn't stop there, as Johann also had problems with his son Daniel. Johann's jealousy for his son began to arise as he noticed Daniel's abilities beginning to flourish. It got so bad that Johann even tried to take credit for Daniel's work. Daniel and Johann published works on hydrodynamics independently, almost at the same time. Johann attempted to take precedence over his son, falsely predating his works as being 2 years prior to Daniel's. Johann also had problems with L'Hopital. Johann tutored L'Hopital in mathematics when he was in France, and continued to collaborate with him through letters thereafter. While tutoring, he had signed a contract with L'Hopital, allowing L'Hopital the right to use his discoveries as he wished. L'Hopital went on to author a book on infinitesimal calculus in 1696. The book consisted of results largely contributed by Johann. L'Hôpital stated that he owed Jacob, Messias, Leibniz, and especially Johann for the results in the book, but Johann still felt he didn't get enough credit. When L'Hôpital died in 1723, Johann tried to take ownership of the work, but this credit wouldn't be given until 1923, long after his death in 1748. Nicolaus Bernoulli I was the son of painter and alderman Nicolaus Bernoulli. He was notable for introducing the St. Petersburg paradox, which is a theoretical game that leads to an infinite expected payoff, but still seems to be worth very little to the participants. His early education involved studying mathematics with his uncles, Jacob and Johann. Jacob supervised Nicolaus's master's degree at the University of Basel, which he received in 1704. Nicolaus received his PhD in 1709, his dissertation being a work on probability theory and law. Jacob presumably supervised him until his death in 1705, and it can be conjectured that Johann then became Nicolaus's advisor. In 1712, Nicolaus visited Holland, England, and France. Among the mathematicians he befriended on this trip was Pierre Raymond de Montmort, who wrote an important work on probability. In 1716, Nicolaus was appointed Galileo's chair at the University of Padua, where he would work on geometry and differential equations for 6 years. Nicolaus returned to Basel in 1722 to take the chair of logics at the University of Basel, and was appointed the chair of law in 1731. Nicolaus was described as a gifted mathematician, but not very productive. Any real insight we get on his impact comes from correspondence with Montmort, where letters between the two contributed to the second edition of Montmort's work on probability theory, Leibniz, where in their letters there was discussions of convergence, and Euler, where it seems Nicolaus had found the exact solution to the Basel problem. Nicolaus also edited all of the late Jacob Bernoulli's works, supplementing incomplete pieces with results taken from Jacob's journals. Nicolaus died in 1759, and though he married Anna Maria Beer in 1720, they appear to have had no children together, thus no legacy to pass on. Nicolaus II was the son of Johann Bernoulli, and he was born in 1695 in Basel, Switzerland. Like the rest of his family, Nicolaus attended the University of Basel. He began attending at the age of 13, studying mathematics and law. He got his licentiate in the theory of law in 1715, and he also did research on curves, differential equations, and probability theory. In 1719, Nicolaus held the chair of mathematics at the University of Padua. While at the university, he assisted Johann by writing letters pertaining to the Newton-Leibniz dispute. Correspondence with Brooke Taylor on this matter also led to Nicolaus making mathematical contributions, such as the problem of orthogonal trajectories. In 1725, Nicolaus and his brother Daniel obtained positions at St. Petersburg University to research and lecture mathematics. Less than a year after arriving in St. Petersburg, Nicolaus came down with a terrible fever and died, putting an end to a promising career and leaving Daniel alone. Daniel Bernoulli was the son of Johann Bernoulli, and he was notable for his contributions to hydrodynamics, his work on the physics of sound, and providing a solution to the St. Petersburg paradox. Daniel was born in 1700 in Groningen, Netherlands. Daniel lived there for 5 years before moving to Basel with his family. Once it was time for Daniel to attend university, Johann tried to push Daniel towards business. This was awfully strange, considering that Johann's father Nicolaus tried the same thing on him, and he resisted strongly. Daniel ended up pursuing philosophy and logic at the University of Basel at the age of 13, obtaining his master's in philosophy in 1716. Daniel had quite an interest in mathematics, and while studying philosophy at the University of Basel, he was also learning methods of calculus from his father and Nicolaus II. Despite his resistance to business, Johann attempted to get Daniel to pursue business once more after he obtained his philosophy degree, throwing him into a merchant apprenticeship. This proved to be terrible for Daniel, and he convinced his father to let him go back to university to study medicine. Daniel hopped around while studying medicine, but ultimately attained his PhD from the University of Basel in 1720. And Johann also taught Daniel more mathematics. Daniel studied his father's theories on kinetic energy, applying conservation of energy to his medical work. Loving mathematical physics, Daniel's medical dissertation was on the mechanics of breathing. Wanting to follow in his father's footsteps, Daniel attempted to apply to 2 positions at the University of Basel, but was denied both. He ended up going to Venice, studying practical medicine. In Venice, Daniel published a few mathematical works. His first, with aid from Goldbach, was a work titled Exercitationes, which is mathematical exercises in English. The work was split into 4 parts discussing ideas of probability, fluid dynamics, Riccati differential equations, and geometry concerning figures bounded by 2 arcs of a circle. Another work, submitted for the grand prize of the Paris Academy and winning, was stabilizing an hourglass. The trickle of sand in this design stays constant even when a ship rolls in heavy seas. With recognition from Exercitationes and the Paris Academy, Daniel was invited to take the chair of mathematics at St. Petersburg. Nicolaus II also got an offer to go to St. Petersburg, so the two traveled together in late 1725 to Russia. Alas, with Nicolaus dying less than a year after arriving, Daniel was greatly saddened and not very happy in the harsh Russian climate. Euler came to St. Petersburg with the help of Johann in 1727, and this led to a very productive correspondence between himself and Daniel. They studied vibrating bodies together and derived many equations, including in 1728, deriving the equilibrium curves for flexible and elastic bodies. One of Daniel's most famous discoveries in St. Petersburg was showing that the movements of strings on a musical instrument are composed of an infinite number of harmonic vibrations, all superimposed on the string. Clearly, Daniel was very productive while in St. Petersburg. He actually began working on his most famous publication while he was there. This work contains, but is not limited to, the first correct analysis of water flowing from a hole in a container, discussion of pumps and other machines to raise water, basic laws for the theory of gases, and the equation of state, though not in full detail. Daniel grew too weary of the politics in St. Petersburg, among other things, and decided to head back to Basel in late 1733. Before leaving, he left a draft copy of Hydrodynamica with a printer, and made significant revisions to this work once back in Basel between 1734 and 1738. Once Daniel arrived back in Basel, he was not very welcomed by his father. Daniel had entered an application of his theories on astronomy for the grand prize of the Paris Academy. Johann had also entered for the prize, and the two won jointly. Johann was incredibly angry at being perceived as an equal to his son, and wouldn't allow Daniel to come visit him. To make matters worse, a few years later the Hydrodynamica drama ensued, as mentioned in the discussion on Johann. Johann, trying to lay claim to his son's work, completely destroyed any kind of relationship the two could have had. Despite the issues with his father, Daniel was still able to perform excellent research, such as winning the grand prize of the Paris Academy a total of 10 times for his research in topics such as astronomy, navigation, and magnetism, writing a work on measuring risk, which provided a solution to the St. Petersburg paradox, and expanding upon Newton's theories. Mixing Leibniz's calculus with these theories allowed for quite a powerful development in mathematical physics. One of his ventures led him to produce an integral of Newton's basic equations using the principle of conservation of energy. Daniel lectured and researched at the University of Basel until his death on March 17, 1782, and he appears to have never gotten married, thus having no children to pass his legacy on to. Johann II Bernoulli was the son of Johann Bernoulli. He was born in 1710 in Basel, Switzerland. Johann studied law and mathematics, presumably at the University of Basel, obtaining his PhD in the theory of law in 1727. He worked on mathematics with his father and independently, mainly focusing on the mathematics behind heat and light. In 1744, Johann married Susanna Koenig, and together they produced at least 5 children, 2 of which pursued mathematics: Johann III and Jacob II. Johann won the grand prize of the Paris Academy at least 4 times. One of these times was for his ideas on ether, which was speculated by ancient and medieval theorists to be the material that fills the region of the universe above the terrestrial sphere. The recognition from this prize allowed Johann to take the chair of mathematics at the University of Basel in 1748 when his father passed, where he would work until his death in July of 1790. Despite an impressive correspondence over the coming years with scientists and mathematicians, apparently publishing approximately 900 papers or so, Johann became less productive after taking the chair. Johann III Bernoulli was the son of Johann II Bernoulli, and he was notable not for his mathematical contributions, but for his travels. He was known around the world as being a child prodigy, obtaining a PhD in philosophy at age 13 and a master's in the theory of law at age 14. At age 19, Johann was appointed the Astronomer Royal of Berlin Academy, where he was asked to reorganize their observatory at the request of Frederick II. Always being in poor health and not being a very good astronomical observer, this proved to not be a good task for Johann. Johann ended up writing quite a few papers on astronomy, but these papers didn't prove to be very important. Johann traveled around quite a bit, and his travel accounts ended up being of great cultural and historical importance. Once returning to Berlin from his travels, he was appointed Director of Mathematics at Berlin Academy. His writings during this time consisted of his travel accounts, astronomy, geography, and mathematics, with his travel accounts being the shining star. Being well aware of the remarkable mathematical line he descended from, Johann looked after the mass amounts of mathematical writings that had come down from members of his family. He ended up selling these writings to Stockholm Academy, where they would collect dust until 1877. In this collection, about 2,800 letters written by him were found. Johann III died in 1807. He had married Veronica Beck, and there was a child named Veronica Bernoulli, whom did not pursue mathematics or science. Jacob II Bernoulli was the son of Johann II Bernoulli. He was born in 1759, and he studied law, but was more interested in mathematics and physics. When Daniel Bernoulli died, Jacob applied for the chair of physics at the University of Basel. The administrators decided to draw lots, and Jacob wasn't lucky enough to get chosen in this process. After this disappointment, he was appointed to be the secretary to the imperial envoy under Count de Brenner, allowing him to see Germany and Italy. While in Italy, he became friendly with Antonio Maria Lorgna, the professor of mathematics at Verona, as well as becoming friendly with Nicolaus II, who was a relative of Euler, as well as being his assistant while Euler was alive. The relationship with Fuchs allowed for Jacob to be admitted to St. Petersburg Academy, where Jacob was appointed professor of mathematics in 1788. Jacob married Charlotte Anna Wilhelmine Euler in 1789, but he ended up drowning while swimming in the Neva River just a few months after. The bit of work that Jacob did before his death resides in the first 6 volumes of a work in Helvetica Chimica Acta, which is a scientific journal founded by the Swiss Chemical Society, and Johann III's publications. He is considered the last notable Bernoulli. The line of Bernoullis that became mathematicians from the 17th century to the 18th century is astounding, to say the least. Though not all of them were as consistently impactful, it's rather incredible that we had over 100 years of contributions to mathematics and physics from this one family. Long live the Bernoullis.